Welcome to today's Explainer. We're jumping straight into something absolutely fascinating, and honestly, a bit misunderstood. We're talking about one of the most complex, widespread natural hazards on our planet. Today, we're totally unmasking the mechanics of drought.
Okay, let's dive into this. When you think of a natural disaster, what pops into your head? Probably something sudden, right? A terrifying hurricane, a violent earthquake, maybe a flash flood tearing through a town. But the hazard we're looking at today, it operates on a completely different timeline. No sirens, no sudden crashes. We're talking about the world's slowest natural disaster, a creeping, silent threat that takes months, sometimes literally years, to show its true destructive power.
So here's our roadmap for this explainer. We're going to define this creeping phenomenon, trace what we call the drought domino effect, look at the very real socioeconomic toll, and explore the desertification tipping point. Then we'll wrap up by seeing exactly how scientists measure this invisible threat to set up early warning systems.
All right, starting off with part 1, the creeping phenomenon. And as you'll see, it's way more than just no rain.
Just take a look at this footprint left in the deeply cracked, dry earth. A drought is ultimately driven by a cumulative precipitation deficiency, basically a lack of rain that builds up over time. Because it develops so incredibly slowly, the physical impacts lag way behind those first few dry days. It might take months of below-average rainfall before we actually see the devastating damage to the landscape.
So what's the actual definition here? Simply put, drought is a prolonged period of moisture deficiency that causes a serious imbalance between the natural water supply and what humans or the environment demand. Notice the emphasis there on supply and demand. Drought isn't strictly about low rainfall in absolute terms. If it was, places like the Sahara or inland Australia would be in a permanent state of drought. Instead, a drought hits when the water supply fails to meet the expected demand for that specific region.
I love this quote because it really hits the nail on the head. It points out that drought is possibly the most slowly developing, long-lasting, and least predictable among all atmospheric hazards. Because of this creeping, almost sneaky nature, figuring out exactly when a drought begins and when it actually ends is an incredibly complex puzzle for scientists.
Which brings us to Section 2, the drought domino effect. Let's look at how this cascading hazard actually unfolds.
And this brilliantly illustrates the top-down hierarchy of drought. It's like falling dominoes. It always starts with a meteorological drought. That's just the initial lack of expected rain. But if that keeps up, the next domino falls. Agricultural drought. That's where soil moisture drops and plant life starts stressing out. Finally, if the dry spell just won't quit, it cascades into a hydrological drought, which means our streams, lakes, and vital groundwater reservoirs actually start to dry up.
To make sure we're perfectly clear on how this progression works, let's contrast those first two dominoes. Meteorological drought is an atmospheric issue. It's weather-based, happening way up in the sky. But agricultural drought, that brings the problem down into the dirt. It happens when that lack of rain finally exhausts the soil's moisture, meaning crops just can't survive anymore. Now, you can actually have a meteorological drought without an immediate agricultural one, if the soil started out with a really healthy reserve of moisture. But eventually, that reserve is going to run out.
Now let's move to Section 3, the socioeconomic toll, and what happens when supply completely fails demand.
Let's see how this builds over time. Natural climate variability causes those meteorological, agricultural, and hydrological droughts we just talked about. But as the impact snowballs, it crashes directly into the human sphere, causing some truly severe economic, environmental, and social impacts. This is what we call a socioeconomic drought. It's when the declining water supply fundamentally disrupts human society, and honestly, it's often made even worse by our own water management choices. To ground these abstract concepts in some hard data, let's look at a case study of the devastating drought in the Thar-Parkar region of Pakistan. A staggering 73% of surveyed households reported a severe decline in revenue from their agricultural products. Think about that for a second. When the agricultural domino falls, farmers lose their income overnight, creating an instant, massive economic crisis right at the household level.
But the impact goes way beyond just the crops. In that exact same study, 237 households reported declining livestock revenue. Because the lack of rainfall kills off the pasture lands, there simply isn't enough grass to feed the animals, leading to terrible livestock mortality. For communities that depend on these herds, this strips away their primary livelihood. It creates widespread food insecurity and forces families into desperate strategies, like having to uproot and relocate just to find daily wage labor so they can survive.
This leads us to Section 4, the desertification tipping point, which is an irreversible threat. So, the crucial point is understanding that there is a massive difference between temporary drought damage and permanent destruction. We call that permanent destruction desertification. It's land degradation in arid and semi-arid areas that reaches a point of resource loss that is, and this is key, irreversible on a human timescale. When you put fragile ecosystems under the extreme crucible of drought and combine that with human pressures like overgrazing, the land can be pushed right past a tipping point. Once it crosses that line, it simply cannot recover, even if the rains eventually come back.
The physical symptoms of this tipping point are pretty profound. Without vegetation to protect it, the soft, nutrient-rich topsoil just blows or washes away. The soil surface itself actually seals up and becomes encrusted. That means any future rain will just run off instead of soaking in. It creates a vicious cycle called spiraling edaphic aridity, which is just a technical way of saying the soil is experiencing a permanent, catastrophic drying out. The land degrades so much that seeds buried in the dirt can't even germinate anymore because the earth has completely lost its ability to hold on to humidity.
Okay, moving on to Section 5, measuring the invisible threat. How do we actually track all of this using frameworks and indices?
Now, what's really interesting about this slide is how we actually measure the threat. You can't just look at a raw indicator like temperature or rainfall alone. You need synthesized frameworks. Take the Standardized Precipitation Index, or SPI. It synthesizes historical rainfall data to give us a really clear picture of deviations from the norm. Or the Palmer Drought Severity Index, the PDSI, which brings precipitation and temperature together to calculate a localized moisture balance. It's fantastic for comparing conditions at specific locations. But then look at the Combined Drought Indicator, or CDI. It's a newer approach that integrates model data with actual physical precipitation and cutting-edge satellite imagery.
And finally, Section 6, Early Warning and Preparedness, where we synthesize all this data.
Because drought is so incredibly complex, researchers have to merge these different individual indices into one streamlined dashboard, which we call a composite indicator. The whole goal here is to leverage the strengths of various data points, soil moisture, rainfall, vegetation health, while giving decision makers a single, simple source of truth for managing risk. This is a game changer because it allows societies to move towards drought by design, engineering resilient water systems and agricultural practices that are literally built from the ground up to withstand these inevitable dry spells.
The Combined Drought Indicator we just talked about is a perfect example of this in action. It takes that creeping domino effect and breaks it down into 3 highly actionable alert levels. Level 1 is a watch triggered by a raw precipitation shortage. Level 2 steps up to a warning, which fires when that lack of rain actually translates into a soil moisture shortage. And Level 3, that's a full alert, hitting when satellite data proves the lack of moisture is actively damaging vegetation. It's an absolutely brilliant way to translate a complex physical cascade into a really clear roadmap for preparedness.
So, we've seen how drought creeps from a simple lack of rain, turning into a massive socioeconomic disaster and potentially leading to irreversible desertification. And sure, we have sophisticated composite indicators to track its slow, silent march across the globe. But I want to leave you with a critical thought to ponder today. Knowing what we now know about the domino effect of this hazard, if drought is a creeping phenomenon, are our societies moving fast enough to manage the risk before we hit that point of no return? Thank you so much for exploring this vital topic with me. Keep asking questions, and I'll catch you in the next explainer.